We're going to talk about mathematical induction. Mathematical induction is basically us proving that a statement like the one you see on the screen is true no matter what number you put in there. There will basically be 3 steps every time. First, we'll show that this is true when n equals to 1. Then we will assume that n equals k is true, and then we will show that n equals to k plus 1 is true. And you will do those 3 steps no matter what statement you're given in the very beginning. So first step, the basis step, is we will show that n equals to 1 is true. So if we have 2n minus 1 equals to n squared, we will see that 2 times 1 minus 1 will equal to 1 squared. And so that will be 2 minus 1 is 1. 1 squared is 1. So we've proven that our basis statement is true. The next step will be the induction step. And the induction step will have 2 parts every time. The first part will be to assume true for n equals k. So what we'll write is assume that 1 plus 3 plus 5 plus 2 times k instead of n minus 1 equals, and then instead of n squared we'll say k squared. We have to assume this is true so that we can work on the second part. The third and final part will be to show that k plus 1 is also true, that n equals to k plus 1 is true. So let's write it down. 1 plus 3 plus 5 and 2k minus 1, that's this part right here, plus, and now we'll put in our k plus 1, where we'll have 2 times, instead of k plus 1 we'll have, instead of k we'll have k plus 1, and then minus 1. And that will equal, instead of k this time, we'll have k plus 1 squared. Now this part right here is the same thing as this up here. And that equals k squared. So we could replace it with k squared. And the next thing we'll need to do is to simplify this part right here. And show that it equals, all that equals the right side. And so we have k squared plus, and then we'll distribute that 2k plus 2 minus 1. When you square a binomial, sometime or another, you remember the binomial theorem, we'll square the first term, double the product of k and 1, and then square the 1. On the right side, we'll combine the 2 and the negative 1, and we get k squared plus 2k plus 1. And we've now proven, through mathematical induction, that our original statement is true for all k's. I really hope this helps.